Hey guys, this is Mrs. Hardman. Welcome to Advanced Math, and today we are going to continue our unit about geometry, and we are going to talk some more about area. We've already been doing this already as we've learned about quadrilaterals and triangles and reviewed those, but we're going to focus specifically just on area today, not so much the names of the shapes. Our biblical correlation is that all things were created by God, including area, and everything that we see or do not see is part of his ultimate design that holds the universe together. The reason that we can function in this world and the reason that we can do the things that we do, like build houses and design cars, is because things do follow patterns and order and structure. If there were no patterns, if there were no structure, if there were no order, then we wouldn't be able to consistently rely on what we call the laws of nature and the laws of gravity and laws of physics. Those things are in place because God created them that way. And perimeter and area and geometry all fall under those things that we don't always see, but we know that he designed for our use. Objective for today is that you, the student, will calculate the area of various geometric shapes. Again, we've already been talking a little bit about area when we've talked about quadrilaterals and when we've talked about triangles. Today, though, we're going to focus specifically on area without necessarily learning the names of the shapes or the properties of each of those shapes. So first of all, let's answer the question, what is area? Area is the size of a surface. It's the amount of space in a surface, if you will. And we talk about area when we talk about a house, like how many square feet are in a house. It's the amount of floor space there is. We talk about area when we want to paint, and we need to know the amount of wall space there is. So it's the size of a two-dimensional surface. Now, here are some shapes that all have the same area of 9. You can see that they've been divided into squares here. So this is 9 square units. This one is arranged differently, but it also has 9 square units. This one is arranged even differently, and it also has 9 square units. So things can be the same shape, but have different, things can be different shapes, but have the same area. Now, when we talk about the area of simple shapes, there are formulas to help us remember how to calculate the area of those shapes. So normally what we're trying to figure out, if you go back to here, is how many rows and columns. So this is you've got 1 row here, and then you've got 9 columns. So this is a 1 by 9 shape, so the area is 9. Here we've got 3 rows and 3 columns, and 3 times 3 gives us 9. And here you've got 2 different sections here. You've got 2 columns and 3 rows, so the area of this is a 2 by 3 space, so 6. And then you've got a 1 by 3 kind of rectangle down here at the bottom. So we've got 6 and 3 equals 9. So you maybe heard things described as a 2 by 4, for example, in construction. And what we're looking at is the dimensions, the length and the width, how many rows and columns. And that's really easy to do when we're talking about rectangles and squares, and we'll talk about how to do that with some other shapes as well. So when you want to find the area of a rectangle or square, you just take the length times the width, like we saw previously. This is a 5 by 3 rectangle. We would write that as 5 by 3, and you can see that the operation there to find the area is multiplication. So we have 5 units by 3 units. We take the width times the height, or the length times the height, or the length times the width, however you want to word it. And we get that the area is 15, and we don't have a unit here. So if this was 5 units, and this was 3 units, we have 5 times 3 is 15, and units times units is written this way. Units to the second power, which we will always read as units squared. So the area is 15 units squared. Again, when we're talking about area, we're talking about the surface area of a two-dimensional shape, and our unit will always be units squared. All right, now that works really well for just like rectangles and squares, but what about when we have more complex shapes? I know that on your screen, the bottom of the shape is cut off a little bit, but you can see we've got shape A is a square, a 20 by 20 square, and shape B is a triangle here. The base of that is equal to the side of the square, so we've got a 20-meter base, and then the height, you can see here, even though it's labeled outside, oops, I didn't quite get that straight, is 14 meters. So we've got a 20 by 14 meter triangle. So if we can break a shape into two or more simpler shapes, we can find the area of those simpler shapes and add them together. So we've got the square and the triangle. To find the area of a square, we know we just take length times width, or side times side. So this is the 20 by 20 square. That means it's 400, and then meters times meters is meters squared. Remember what we said previously, that a triangle is just half of a square, half of a rectangle. So we find area the same way, length times width, or base times height, but we just cut it in half. So it's 1/2 base times height. Our base is 20 meters, and our height is 14. And we're going to take 20 times 14 and halve that. So half of 20 times 14 is 140. Again, our unit, meters squared. We're using square units when we talk about area. We're then going to take part A and part B and add them together. So 400 plus 140 is 540 meters squared. That is the area of this more complex shape. Another way that you can find area of complex shapes is to break something like this into triangles. And once we have it broken into triangles, we can then find the area of each triangle. So we could measure the base and height of each triangle and find the area of the triangle using that formula that we've already learned, 1/2 the base times the height. And once we find the area of these three triangles, we then add them all up. Let's talk about area of some different shapes. Now, a parallelogram is very similar to a rectangle. In fact, if we were to cut this triangle off and move it over here, I'll kind of dotted line it in there, you can see that what we would have is a rectangle. So we find the area the same way. It is just base times height. So 10 times 8. Notice that the 8 is not the length of this side. That's not what we're using. Much like a triangle, we're using the side or the height that forms a 90-degree angle here. The actual height of the parallelogram, not the slanted side. So 10 times 8 gives us 80, and our units, feet times feet, feet squared. So the area of this is 80 feet squared. A triangle, we've already mentioned, is just half of a rectangle. So if this were a rectangle, it would be 4 by 2, or 4 times 2, but a triangle is half of that. So 1/2 base times height. So 1/2, 4 times 2, and again we get 4. Our units don't match here. This says miles, and so we need 4 miles squared, not 4 meters squared. So do make sure your units do match. A trapezoid is another quadrilateral, and to find the area of a trapezoid, we have 1/2 the height times the sum of the two bases. So 1/2 height, and then base 1 and base 2. Your bases are the sides that are parallel to each other. So this line and this line, we'll use our markings here, this line and this line are parallel, so those are our two bases, not the two sides that are not parallel to one another. So when we plug that in, we get 1/2, our height is 9, and our bases are 4 plus 8 here, and 4 plus 8 is 12, half of that is 6, and 6 times 9 is 54 meters squared. Like a trapezoid or like a parallelogram, if I were to cut off this triangle, sorry, I can't draw very straight, and move it over here, you can see that it would form a rectangle or a square or whatever. It would form a nice, neat shape. The reason that we cut that in half is because we just need like the average of these two bases. If this one's 8 and this one's 4, we just want half of that, and then times 9. So 1/2 the height times the sum of the bases is the area of your trapezoid. The circle formula involves the use of pi, like anytime we do work with circles here. And so the area of a circle is pi r squared. As a reminder, the circumference of a circle, that's the perimeter, is 2 pi r, and the area is pi r squared. We can figure out r, or radius, if we know what the diameter is. The diameter is the distance all the way across, and the radius is just half that distance. So half of 9 is 4.5. So we're going to use the pi button on our calculators, which is more precise than the 3.14, times 4.5 squared. And when you plug that into your calculator, you would get 53.6 and a bunch of other decimals. This one's been rounded to the 10th place, so 53.6. Again, our unit of measure is centimeters, and this is squared, centimeters squared. So, as a reminder, when we are finding complex shapes, we want to try and divide our shapes into smaller figures. And this large shape has been divided into, you see, a square. Shape number 2 is a rectangle, and shape number 3 is a larger rectangle. And then we find the area of each of these shapes. So this, I said it's a square, but it's really not. It's close to it. 5 by 4 rectangle is 20 yards. And then this one, we have 5 yards here and 23 yards here. That gives us 115. And then we've got a 32 by 12 yard rectangle here. That's 384. We add up those areas and we get 519 yards squared. So break your shape into smaller shapes, find the area of the smaller shapes, and then add those together. Right? We can also use area formulas to eliminate parts. So let's say that this, for example, we had a swimming pool and we wanted to build a deck around our swimming pool. So we would have to find the area of this whole blue rectangle and then take away the part where the swimming pool will be. So first we're going to find the area of the 28 by 28 rectangle. Now this is not really a deck or a swimming pool because the units are millimeters, but just I'm trying to create a visual picture for you. So we would take the 28 by 28 area, and then we would subtract or take away, remove the 18 by 18 area. And we get 460 square millimeters when I do that. So the blue part only is 460 square millimeters once we remove the white. Again, this is useful and a lot of practical applications. Another less practical way that we can find area if we're dealing with a shape and we have a grid available is to put our shape on the grid and count the number of squares. This does not give us an exact area, but it does help us to approximate the area. Now this, because it's a rectangle, we can see very clearly this is exact, that there are centimeter squares and that the rectangle has been divided into 15 centimeter squares or square centimeters. But shapes that aren't rectangles can be a little bit more difficult. It may not match the shape exactly like it did the rectangle, so we just have to approximate. So let's take a look at a shape like this. We've got a pentagon laid on top of a grid, and we're going to say that it's approximately an area of 17. So if you look, this 2 is not a full square. But if I take this other little triangle that's next to it and imagine putting that here, that would make about 1 full square. Same with the 16. The 16 is not a full square, but I've got this little rectangle next to it that if I put that here, that would be close to a full square. And so we count that kind of as 1 square. These two little parts would form 1 square. Again, this is an approximate because we do have parts that are not full squares. So this would be approximately 17 square units. Taking a look at the circle, you can see we've approximated it again. We've put it on top of the grid here, and we see that it's approximately 14. Again, you can see right here, we're just kind of eyeballing this. We've got 2 smaller parts on 4, and those, if we put those together, would maybe equal close to 1 square unit. And the same with the 8. If we put those 2 smaller parts together, they would equal close to 1 square unit. And so that allows us to approximate that this is 14 square units. All right, guys, today we calculated the area of various geometric shapes using formulas like the area of a rectangle is base times height. The area of a parallelogram is base times height. The area of a triangle, 1/2 of base times height. And the area of a trapezoid is 1/2 the sum of the bases times height. We also talked about the area of a circle, which is pi r squared. We can use all of those formulas to break complex shapes into smaller shapes, find the area of the smaller shapes, and add those together. If you guys have any questions, be sure to write those down, and I'll see you next class.